I'll give a brief overview. It's 2017, and I sort of, so like in context for geo industry people, like federal tax credit residentially goes away, sales are down. Um, NYSERDA comes out with this, demonstration technology heat pump RFP, which we always love the term of. And a team of us got together and we submitted a ground source heat pump proposal proposing to install ground source heat pumps at 40 sites on Long Island, use the waterfront acidity monitoring data, and basically be able to determine how does the system actually perform in the climate zone. Give a comparison to the study that NYSERDA had done upstate New York around how, system like Long Island wasn't really represented in that, around 50 systems, and then also survey the homeowners to get their sentiment around, are they comfortable with the technology? Are they not comfortable with the technology? Um, did they like the installer? How were their energy bills? All of those things. So we went out and we did site selection, and the definition expanded over time. At the very beginning, we couldn't do fuel switching from natural gas to geothermal. Later into the pilot, we were able to add those customers. Um, we were also able to tie into people that had done existing energy audits and use some of that data to help identify, homes that were, more prone for electrification. Um, So that's, in big picture, that was kind of the premises of the study. We wanted to see, there was enough funding from NYSERDA that we were able to play around and see, was there, a cost shift in customer behavior? If you gave them a $2,000, $3,000, $5,000 kind of incentive to participate, or were you able to give them 2 years of maintenance or 3 years of maintenance? So we were able to play around with some of those things to figure out what really would cause someone to participate, and let the data be collected. And at the time we were thinking that we were going to do on-site verification just because of time frame to award. And then with COVID happening, we ended up not doing the on-site verification piece, but that was, kind of the study as a nutshell. So I think I'll just ask, like, does anyone have any big picture questions about the study before we dive into it a little bit? Nope. All right. Um, so one of the things is I'll put a link in chat to where the study lives in case anyone hasn't seen it.
And it was also on the invite, Zach, so people can get a double. Yeah.
Perfect. Yeah. Um, so yeah. Um, so one of the things was that, so there were a lot of findings. One of the things we're kind of looking at it, today, knowing what our cost per ton installed was, the average cost per ton to homeowners installed ended up being about 6,000 after incentives, which might be a number that holds true in Westchester or New York City or markets that have higher incentives, but does it hold true in Long Island and, the rest of the state at this point? So the data is a little bit old. The other thing is the cost of electricity. Um, I don't know if we actually say it in the report, but it was probably around 21 cents at the time, a kilowatt hour. Um, so electricity has gone up 20 or 30% since this report has gone out. And unfortunately, natural gas has not increased, kind of at the same range. Um, the study, basically found that downstate the systems had slightly warmer loop temperatures in upstate New York, and our average COP was a little bit higher than upstate New York, which would be expected. Um, the It also found a savings over the studies NYSERDA did for air source heat pumps. NYSERDA did, Scott, it was two pilots for air source heat pumps, if I remember correctly, one in the Hudson Valley and one in Brooklyn.
Yeah, for mini splits, yeah.
for mini splits. So,
Yeah, we had two smaller projects that were doing other things. We had one that was a hybrid gas furnace heat pump, and then another one that was an air to water heat pump demo. We had two big mini split ones that are most comparable to this.
um, yeah, yeah, and as an industry, we spend a lot of time talking about peak demand reduction. So we found that the peak demand was 0.7, kilowatts per installed of cooling ton. And that was about 20% lower than the demand for air source cold climate heat pumps. So now we actually have, some data, around, two third-party M&V studies. Ron, you asked the cost before incentives, little over 10,000. Um, $10,570 a ton was the install before incentives, and then the incentives were federal tax credit, utility rebate, and any contribution that we gave as a discount to the customer to participate. Water furnace also did give a discounted multiplier on this. That also brought the cost of equipment down a little bit.
And Zach, just to jump in and say what you just said, again, or reiterate, you were giving installed cost per ton values, not total installed costs. So you
Yes.
have to multiply it by the size of the system to get the total cost. But if you want to see the total costs, they're in table 4. Table 3, sorry, table 3 report, starting on page 11.
Let's see what else. Probably one of the other differences between the study and the upstate symphony study is all of our installations had propylene glycol on them, where most of them in the upstate study had methanol as the antifreeze. Trying to think of other big differences.
Zach, if I can jump in, when I read it, it looked like standardization was one of the objectives. Would standardization actually lower costs? And was that ever answered?
We toyed around with it. And honestly, I don't think we ended up with a large enough sample to really, do it. So we were trying to go after when we started, the houses that had a single furnace in the basement, already had air conditioning, already had insulated ductwork, that all you had to do was pull out one furnace, the furnace, and put in a geothermal unit, whether 3, 4, or 5 tons. We tried to standardize around variable speed compressors at the beginning, so you could do 3 and 5 tons and not necessarily need to worry about the 4-ton units, which was fewer SKUs to stock. You design all your loop fields about the same. And there is something to be said for repetitive installations and, just having been in Geo for 15, 16 years now, our installers are faster installing a heat pump today than they were installing it, 10 years ago or 5 years ago. There's little tricks that we pick up. There's things you can prefabricate. Everyone kind of knows how to, work in the orchestra. I don't think there were any, large material savings as a result of the standardization. And if you'll see some of the later sites that got added have 2 heat pumps, some of them needed ductwork, we weren't always able to fit that model. And we then needed to, kind of expand our pool for conversions, or, people had a unit in a unit in the basement, a unit in the attic. So you needed 2 units, so you needed to add ductwork. Or common on Long Island is you have a gas furnace in the basement, and then they added, which was just heating. And then you had air conditioning put on a separate system up in the attic. So we would remove that air conditioning system, add additional ductwork and high returns. So that brought up the cost per ton, but also adds, makes 2-day install to a 3, 4-day, install at that point. So there's a bunch of different things. Jared, did that answer your standardization question?
Yeah, thank you.
I guess, Hugh, I'll ask if you have anything that you wanted to share, having done a lot of the data analysis.
Yeah, so I think, one of the goals of this study compared to some past studies was to sort of be a little more comprehensive. You often have performance data, but not costs. You often have performance data, but not sizing. So this was one of the first sites where we actually knew what the manual J loads were. And we were able, so we had a better handle on performance and all the sizing details together, whereas we've rarely had those things together in the past. And then obviously the cost too. It's always a little hard to get cost data, and it was still hard here, but we did it.
Yeah, and those are maybe important contrasts to this, to the upstate study that was looking at projects that had already been installed. We didn't have anything, we didn't cost share the installations, those projects, the upstate study. We didn't really know anything about, all we knew about the installation, we gathered after the fact. We didn't really have information on upfront costs. So glad you brought that up.
I'll throw a question in there. When I sit in on long-term gas rate planning discussions from the different utilities, there seems to be a tendency to lean toward either air source heat pumps with gas furnaces for really cold days under 30 degrees, or a reliance on cold climate air source for the heating. And I don't see anything about geothermal, yet the myth exists that it's way too expensive, and the appropriations that are in those long-term plans wouldn't even come close to funding ground source heat pumps. I'm not a technical guy, so lots of the technical stuff in these reports are difficult for me. But can we now say, as a result of this study, that we should recommend having ground source heat pumps because they are cost competitive? Should be considered?
Well, yeah, well, so I guess the costs, the costs were high on these projects, like Zach said, $10,000 a ton or so. And partially because the Long Island market is more expensive. We also found the obvious that compared to if your base fuel is natural gas, there's not huge savings at the moment, right? So using current gas costs, I would say the cost effectiveness was not overwhelmingly compelling.
I
Would
would
that,
argue,
does that mean competitive or not competitive? I'm sorry, I don't mean to.
Yeah, well, so we didn't bother calculating payback, I think. I think, as I remember, because it wasn't a pretty picture.
Okay. I don't mean to put you on the spot. I'm just trying to ask some questions.
I mean, JR, like in the report, it says, again, keep in mind, these are 2020 numbers. A home with fuel oil saved $173 an installed ton. Our average home is about 4 tons here, which means you save $650 a year. With the cost of electricity. So if you're talking, a system that's $5,000-6,000, a ton, and so you're $20,000 after incentives, and you don't need to otherwise replace your system. And again, these 2020 numbers, you're saving $650 a year. That's a 13-year simple ROI.
Okay. Thank you.
I would, but I'll just say that from like a policy perspective and from like gas planning, if you're going to encourage people to sunset their fossil fuel appliances and pay whatever to install the air source heat pump, then the comparison is different. We're not comparing, like, the study does not touch on what is the cost of operating an air source heat pump versus a ground source heat pump in these same houses, which you could look at the studies that were done on the air source heat pumps and the studies that's done on the ground source and kind of back into what those numbers are from energy savings between the two. We have the peak demand reduction in here, and we can figure out total kWh. And then say, what is the incremental cost, and look at what the ROI of the incremental is if you're already going to incentivize the baseline. And that's really the analysis that would need to get done and then shown to the utilities or whatever the groups would be.
Yeah, so I just looked it up. The payback for compared to systems that had used fuel oil was like 35 years, and it was 20 years for the systems that had used electric heat. So, and even worse, obviously, for gas. So, but I think the point of this study wasn't necessarily to that was to dig into some of the details. And I guess I'll say what also fell out of this study was a lot of, testing the assumptions used in TRM savings calculations and things like that. So we were able to verify some numbers like that have been backing up the TRM and things like that. So again, because we had the building heated, the manual JLOs, we were able to come up with the building equivalent full load hours and kind of show that the TRM numbers are probably on the high side and should be adjusted down, which is what some of the evaluation studies are also finding.
Almost everyone that participated in the study was at or very close to end of life of the equipment. So they would have had a baseline cost to replace their equipment. So Hugh, I think the return on investments that you're talking about are standalone, not assuming that they needed to make an investment, but if someone needed to spend $5, $15, $20,000, whatever the number was to replace their system, that made almost everyone that participated had under a 7-year ROI. When they looked at it from their individual perspectives, however they internally justified it, that they needed to upgrade their electric service already. They needed to, they had other reasons to do it besides just, my system's 6 years old, and be able to go from there.
Yeah, that's right. Those numbers I gave did not take into account the credit you would get for not buying the alternate system. That's right.
Yeah, I'd like to say we really need to get a comparison between replacing a conventional system with an air source versus a GHP, because that's where we're seeing most people switching over, and they're being pushed to go to air source because it's quicker and easier, maybe a little cheaper. But if these people are not given really exposed to the choice air source versus geothermal, at least not on Long Island, PSEG is really pushing the air source heat pumps because they get better numbers. Is that what I'm told? Better adoption numbers. But if people don't know, how can they choose?
Good point. Do we have other comments or thoughts, suggestions?
Chair, if I could, Hugh, could you please explain what you mean by TRM numbers? There are a number of kind of newer folks on this call, and it would be helpful to understand what you mean by that.
Yeah, so all the utilities get together and they came up with a way to calculate savings for air source heat pumps and ground source heat pumps. And that's called those savings measures are in the technical resource manual for New York State, which is called the TRM. And so there are documents together, and these are online at the DPS website, and you can see them. And there's one for geothermal and there's one for air source. And I was kind of involved in both of those, but So in those savings calculations, there's various assumptions that are made about how to calculate the savings. And a lot of the goal of these studies were to sort of verify those assumptions. So like I said, one is the equivalent full load hours, or it became the building equivalent full load hours that a heat pump runs. It applies to both air source and geothermal. And this was one of the first studies that we could sort of verify. We had everything we needed to verify or to do an independent calculation of the BEFLH values. So for instance, that's one of the examples. And of course, the other is what are the efficiencies of, you know, at the various stages and things like that. And so and the other one is that the average loop temperature upstate we found in the previous study was about 41. For Long Island, as Zach said, we found it was closer to 44 for heating. Also, what's the percentage? How big is the cooling load relative to the heating load and things like that?
So in general, the study showed that the TRM, the technical resource manual values that had been projected were basically on point, or did you come up with some significant differences?
I'd say some are good and some are bad, and we'll use that to refine going forward.
Thanks.
So I think, as Zach said, the one thing, you know, we saw that COPs in the upstate study, the average of the fleet was 3.6. Here we found the average was 3.8. Upstate, the loop temperatures were about 41 on average, or 40. Here they were 44. So, and we found kind of similar differences between dual speed and variable speed unit for the water furnace systems too. So I think we verified a lot, and there were some things that we found that are different, and we'll probably try to correct. Yeah. So the other thing is, Zach said, you know, so the average peak demand per installed ton was about 0.7, 0.75 in on the coldest day. For instance, for air source, we see that's a 20% more, like 0.95 or 1 per installed ton.
Thank you, Hugh. Appreciate it. Anyone else have some questions or comments, thoughts?
I have a question.
Go ahead, Jean.
Thank you. I have assumed that a larger project that uses multiple
Thank you very
boreholes
much. Have a good day.
is going to lower the cost because you get efficiencies of scale. Is that correct? So rather than individual homes having a loop system, a large multifamily unit would have, a building would have lower costs per unit because more residences are sharing overall a smaller number of boreholes.
I can talk a little bit about that. We do a lot of multifamily. We have 30-something buildings in various stages of design and installation at this point, mainly in New York City, a little bit into Westchester, a little bit into Connecticut. So what we see is the bore fields are smaller on a per square foot basis because you do get the diversification, and a lot of the products we're doing are new construction, and a lot of the energy codes, you know, push them to go more passive house these days, or passive house light. So maybe you're not going for the certification, but you're still building triple pane windows and, you know, a relatively tight energy, you know, envelope. So you see that the buildings, anytime you go above 3 or 4 stories, you tend to switch to cooling dominant, and then you put domestic hot water on it. And the domestic hot water tends to make your loop field smaller, not larger, which it would do on a single family residential house. So we end up, so like rule of thumb, Long Island, Long Island, New York City residentially is you end up somewhere 150-ish feet per ton. On a lot of our large commercial projects, we're seeing 60, 70, 80 feet per ton for multifamily. That doesn't hold true for, actual commercial, but for multifamily, we're seeing relatively small loop fields comparatively. When you start talking the inside mechanical side, the cost per ton installed tends to be greater than what you would see in a residential house, but that's partially because the mechanical systems are different. You're in urban environments, you're working, you're dealing with higher insurance costs, you're dealing with, differences in building codes where you'll have energy recovery ventilators, you'll have common risers, fire dampers, mechanical installation components that don't otherwise, exist in single family residential. We see, often that when we do a cost analysis, that with the available incentives, a geothermal system tends to be on par, if not cheaper, than the baseline system that developers are choosing, as long as they aren't choosing PTAX through the walls. But if they're choosing VRF, or they would do a boiler tower system, or some sort of mechanical system that had any sort of complexity to it or efficiency to it, we're seeing significant first cost parity, if not savings.
Thanks, Zach. Other questions? Good one. Jim Thomas, your hand is up. Go ahead.
Let me get my sound on here. Hey, I had an interesting conversation with Tom Wire. He's the president of GeoFlow, makes flow centers. So for some of us, we're kind of enamored with ECM motors. A lot of our geo equipment comes standard with old PSC motors. A lot of flow centers come with old PSC motors. We know that they're not nearly as efficient as ECM. Apparently, the Department of Energy is now going to dictate that all new pumps will be ECM, which could create a problem for replacements on flow centers. He's trying to get Grundfos to actually agree to manufacture a volute that will fit in a PSC motor in a flow center. Otherwise, people have to change their flow center if the motors go out. However, from what I've seen, we get substantially better efficiency with ECM blowers and ECM pumps. I would ask the people who did this study, what kind of equipment were you looking at? Because pretty much standard equipment still comes with PSC. You have to order special ECM blowers, and the same thing with flow centers.
Yeah, so I guess, Zach, that's probably for you, but this was a mix of variable speed and dual stage. I believe some of the pumps were also variable speed from water furnace, right, Zach?
All the pumps were variable speed.
On
We
the study.
we standardized our business, and we went to all variable speed flow centers with our water furnace units, as a way of keeping our parts that we had to stock down, and the guys couldn't grab the wrong flow center when they were going to the job from the shop. So my install business at the time was probably 70% 7 series variable speed compressors, where like the little bit that we did that was dual speed, we just put the better pump on to not have that installation issue. I'm looking through the list right now. Pretty much, like, with the exception of the split units, and I guess 2 other units, all the package units, with the exception of 2 units, and the 2 units that are not variable speed compressors are 2-ton units, where they didn't make a variable speed compressor in that size. And then the split systems, they didn't make a variable speed split at that time. Everything else besides that is variable speed.
So it sounds like the loop temperatures you're quoting are actually pretty good. How However, and if you're already using ECM blowers and ECM pumps on the loop, what is it we can do to actually get our efficiencies up? It sounds like we're kind of maxing out already, at least from what I'm hearing here.
Yeah, the challenge on Long Island is our loops peak on cooling, not on heating temperatures, which is different than, the rest of the state in single family residential. When you get north of like Westchester, you start driving based on heating temperatures. So I'll hit 90, but I'll only ever hit 35 or 38 in the loop. And then you lose cooling capacity.
Right.
So we need to be careful about how we're designing our loops from, a cooling perspective.
Well, I'll make another comment. I don't know if you saw Jeff Hammond's email. They're going out with a new US Canadian standard. You might want to take a look at that because
I saw it.
they're recommending much lower loop temperatures on heating and much higher on cooling. And that concerns me as well. I'm not sure we want to do that and lose even more efficiency.
The Clean Heat Program Manual did it a few years ago, where you're not, you're allowed to go down to 25 instead of 30. You know, I have my own thoughts about it. I'll leave it as on Long Island, almost every one of our jobs requires a professional engineer to stamp it at the end of the day, which provides, a level of design risk. A lot of the engineers we work with were not stamped with loop field that goes down that code, even if the CSA standard allows it. And unless manufacturers, as part of their refrigerant switch over just in general, are going to change where their freeze protection lockout is. So those of you on the call that are not technical, most of the manufacturers have a 15-degree lockout, where if the water temperature gets below 15 degrees, the heat pump locks out. Most of the times when you flow in a geothermal application, you're running an 8 to 9 degree delta between your inlet and outlet temperatures. So if you're allowed, if your loop goes down to 25 degrees, that means that if you have any interruption of flow, you're going to go below that 15 degrees freeze protection level, which is kind of the manufacturer's, lockout level. So if you're going to go colder, so for a long time, it's been 30 degrees, which is kind of where the industry would design low temperature to, which gave you 20 degrees leaving the heat pump and gave you a few degrees of safety just in case flow degraded, your antifreeze level wasn't perfect, or, whatever happened, and you wouldn't have a customer complain that they had no heating or lockout. So, Jim, I agree.
Jim, I guess, so you're talking about CSA or CSA 448, right?
Yes, yes.
And you're not saying, so it's not recommending lower temperatures. You're saying it's permitting lower temperatures, or what exactly are you
Yes.
saying?
Yes, it is. It's shades of 25 degrees that Zach was just talking about.
As the minimum permittable
Yeah,
design
some
temperature?
on Canada, it was even lower than that. I don't know what we're trying to do here. I wasn't really happy with the 25-degree loop. And I'm in New Jersey. We're never going to see that down here anyway, because our ground is warmer. But with that said, I had a unit this winter lock out at 26.3 degrees, and water furnace said, "Too bad you're on the hairy edge." That's what they basically told me. So they weren't going to warranty it. So even though they do rate the equipment to 20, they don't even recommend you running down to 20. 25, maybe not. And what we don't want is a bad customer experience with a lockout, because it generally means the loop's got to heat up a little bit somehow, and then manual intervention to get the unit back up online. So we need high reliability. I think so. I would invite you all to take a look at the standards and comment on it. That's what I would say. So.
And Jim, I'm not trying to put Colin on the spot here, so Colin, don't feel obligated to answer this. But it'd be interesting to get data from Con Ed around and from the JUs in general, not just Con Ed, about who opted to take advantage of the lower loop temperature exemption, and if there were any customer complaints associated with those installed systems at some point.
Well, the person that would know is Ryan Sharda, because he was the one that basically pressed for this, and he's the chairman of the standards at IGSPA. So I'm sure I haven't talked to him yet because I just saw this about 2 days ago. So we have a couple months to comment on it. So I would encourage everybody to download it, and you can comment line by line. So And there was no rationale given for why they were changing the temperatures. I assume it's to short loop, right? Why else would you have a lower temperature than just trying to
And I
plug
think,
it in a loop?
and I think it's for very cold climates. So I think they were toying with a more complicated formula. So I think in no way is 448 encouraging temperatures that low. It's just saying it's permissible. And in some clients, in some climates, it can be rational, but I don't think it's encouraged for New Jersey.
No, it's not encouragement. People see that like a building code, and everybody builds, they say they built a code, but code is basically minimum. And so if people can either save money for the customer and make more profit, they're going to kind of go with code. It's not necessarily a recommendation, but they can still say, hey, I can get my incentive. I'm still within the minimum. Good for me. Obviously, when you do your manual J, you do your loop calculations on residential, you're guessing what the thermal conductivity is. So all this is kind of guesswork. Even if you're within 10% accuracy, you're probably doing well. So you design for 25 and everything's out of phase and you're on the wrong side of that, you're going to be beyond 25. So to me, I would be more conservative. And I wouldn't call it a recommendation, but people do build the codes or standards, right? That's why we have them.
Thanks, Jim. I'm glad we're getting this recorded. I can go back and re-listen.
Yeah, they're going to come after me now.
No, just capturing your expertise.
Well, I was very concerned when I saw it. I've been concerned because I don't know if Gaylord is still on here or not, but Gaylord and I were doing quite a bit of work with multi-source, and what we're trying to do is actually get COPs up, not do things to let it slip down. And obviously, the cost of electricity is high. It's in our state and your state. That's not good in comparison with gas. So we need to counter that with higher COPs and higher EERs. That's how you counter that, because we can't really control the cost of the electricity. So, or gas either. So I think we should do things to try to get it up. I'm a little disappointed that Zach is reporting something less than 4 for efficiencies, because I think we can do better. That's my personal feeling.
Okay, Jim, thanks. Jackie, you have your hand raised. Go ahead.
I wanted to address an earlier thing that I think Zach said. Did you say that it was, or did I mishear, a 34-year payback over fuel oil on the Long Island installations?
I think that's a number Hugh said, and it was related to looking at it as a standalone investment.
That's right. So that's taking into account incentives, but not taking into account the and end of life replacement. That's correct.
Okay, so in other words, that's replacing fuel oil systems that are not near the end of their lives. So it has to account for a large portion of the fuel oil system that's not used up. Is that what you're indicating?
That's right. You're taking no credit for taking no salvage value for the old system.
Now, correct me if I'm wrong. It seems like that's a little high for a payback. Or am I just not? Would that mean that I'm not familiar with not using end of life calculations?
Yeah, so this report, so think of this report has given you some fundamental information you could use in analysis. There's all kinds of economic analysis that somebody could do. You could compare it to air source heat pumps. This report was just focusing on the technical performance of this geothermal system. We kind of reported, yeah. So the economics were not the focus of this report. But we have a lot of fundamental information, so somebody could get out a napkin and do some of those economic calculations.
Sounds like a challenge. Okay, folks, looking at the clock, I've got about 13 minutes left. Open it up for any other. Oh, Gabe, I'm sorry, I missed you. Go ahead.
That's fine. I literally just raised my hand. But I also heard at some point somebody mention an 8-year payback. So what was that in reference to? Because I heard the 35 and the 22. So I'm new. I'm just getting a grip on this stuff.
Gabe, I did a quick calculation around what an incremental return would be. Just taking into account, you know, what we would expected one of these homeowners to pay for a replacement system. You know, a like replacement system, you know, someone has a gas furnace, they put a new gas furnace in, and then you look at the incremental ROI. I'll tell you, we have no customers that go ahead if their internal math tells them they have a 35-year return on investment.
So an 8-year, that's on par with solar installations in a lot of places in New York, residential at least.
Yes, we saw most of these clients convert to geothermal when their equipment was at end of life. And they were faced with you know, the expense of needing to replace it, and then took a, you know, a big picture view of what was required.
Thank you.
Just so everybody's clear, and I appreciate what everybody's saying, but, the difference is if you're facing having to replace your fossil fuel system, subtracting those costs from what the ultimate costs are for the geothermal system, that's where the 8-year payback comes in. And it really makes sense because that's largely what people are doing. The 35 pieces is just not taking into account the fact that you're going to have costs to have to replace the fossil fuel system.
Thanks for the clarification, Bill. So we've got about 10 minutes left. Again, Zach, thank you. Thanks. If I missed Hugh in the beginning, I certainly did not mean to. Hugh, Scott, Sue, Andrew, Donovan, you guys doing this study is really appreciated by everybody at New York Geo. And that'll give us a couple minutes to hear from John Ciovacco. I also want to make note that I appreciate our New York Geo board members being on today. We've got Heather Deese, Bill Nowak, Zach, of course, and John Ciovacco from our New York Geo board. So, John, how about some information on the conference quickly, and then any other thing that you've been wanting to share with us from all your endeavors?
Well, all right. I did want to. I've been sort of feverishly trying. My grid for the conference is just a mess, so I've been trying to pull it out into something that was more cohesive. While the rest of you were opining about the study, so I'm going to share my screen and just give you a review of some of the topics that we're playing around with. They're not necessarily definite topics. And there's room for some other things, but let me just, if I can share, and it looks like I can.
Yeah.
And just to be clear, Zach and others, we have a committee that's put together. Some of the folks here are helping out on lots of aspects of this, and Zach in particular is working with me a lot on the program part of it. But maybe I'll just quickly kind of run through just some of the topics that we're playing around with putting together. Some of these have been suggested, and I have presenters, and some of them are concepts that we're going to piece together with folks, and some of them probably won't show up. So I just some interesting ones. Looking at, we didn't have Geothermal 101. We didn't really have room for it in Albany, but I think I'm going to bring it back. I don't know if I'll do it both days like we have, but that's probably popping back, probably a J-egg. GeoStar is back bigger and better than ever with 3 award categories. So I think that's kind of exciting. that Joanne Coons is helping marshal together. And then there's just some interesting topics, many of them suggested by Zach, actually. Sweden's experience with geothermal. I think a number of us that have been poking around have found that Sweden has some interesting things going on. Maybe we just focus on that for fun. This is another Zach idea, 5 new technologies that could change the geothermal heat pump market. You know, something fun like that. That would be an innovative thing to do. We don't know what those are today, but by the time we get to the conference, we hope to know what those are. They'll be sealed in an envelope. Seems a good time to review what Con Ed's done with their SC1 new rate that they put out. It's not SC1. It's rate. What's the rate called?
Rate 4. SC1 rate 4.
Yeah. There we go. Fixed. I want to talk a little bit about test bores. I don't think we'll do a deep dive into drilling, but I want to talk about a little bit more about test bores and the math behind doing a thermal response test. I think that would be a good thing to highlight. Policy and program, some basic stuff that we typically would do around utility and NYSERDA, have to have IRA updates. I think Zach suggested that maybe we do something specifically on transferability, how you actually pull that transferability thing off. And I think that's a good idea. I'd like to talk about all the studies that have been happening and maybe focus on that, and then maybe have a special program, a little like we've seen Jens do. And then there was it Kevin Kintz? Who is the gentleman? Yeah, Kevin Kintz also had some innovative ideas about just how to look at geothermal kind of on a national scale, and then also the regional scales and the impacts on the grid. Lots of stuff on large buildings. We're competing against a large buildings ash rate program, but at the same time, we'll give it a go. We'll try to get some of the folks from the Empire Building Challenge, which is a large buildings program, large developers. I've had a few people ask me to put something together, or they want to participate in something around financing large commercial projects. It's just a very difficult thing to do, even though there's lots of incentives. A lot of them show up later, and just trying to figure out how to pay for it all is a bit of a bugger. Brownfield sites, there's been a couple of different angles on that we're going to talk about that I think will be really interesting, because those are actually great opportunities for the right set of folks. High-rise buildings, can't get away from that. High temperature heat pumps for domestic hot water. We probably have few folks have come to me with requests to do something around that. So I definitely want to give that another look. These are feasibility tools, how to quickly size up opportunities, specs that make sense, just how do you write a geothermal spec. I'm looking to do the design track over 2 days. So instead of having just 5 sessions, it would also be another 4 sessions on day 2, so 9 total. There's not 9 there yet, but these are just ideas. Lisa Malin wants to talk about a new ICSPA certification for a commercial designer that I think would fit in well. Design pitfalls to avoid, kind of and there's been different versions of that have been put up, and we'll figure out who might do that. Quality assurance checklists on large commercial projects, finishing strong, commissioning and operator training. Just some thoughts that we have in there. Can't avoid thermal energy networks in today's world. So we'll have an update, certainly of some kind, on the U10 stuff that's happening, and then also look at NYSERDA's existing 4614 and the legacy of that, and as it goes forward. And then their new programs around community thermal networks that will be announced shortly. I also want to talk about things outside of New York. So those are both New York, one's utility, one's perhaps not utility. And then let's hear what else is going on in North America to bring in some of those elements. And I do want to spend a little time on energy master planning. It might actually relate some to some of this big grid planning stuff here, but I do think that thermal energy networks really shouldn't be done in isolation of a larger decarbonization and you know, we need a lot of different renewables all to come together to make these things work, and we need to coordinate those things. And so I'm thinking about having a session or two. I have one that's kind of more on the kind of as a policy statement to energy master plan, and then another one on the math related to it. How do you do the modeling of all those different factors together to make it happen? Anyway, those are some ideas that are kicking around. Happy to have a 2-minute discussion about it. Minute and a half.
While people are thinking about that, I just want to let everybody know that in 2 weeks we've got our next Let's Talk, and we're hoping to have Sue Doherty come talk to us about some NYSERDA programs that are coming up. I don't think you'll want to miss that. If any of the NYSERDA folks want to embellish, feel free.
This is Don. I think you got it. No need to say more on that.
Okay.
I guess, John, I guess the only thing you didn't mention, I don't know if you don't want to mention, is potential site tours.
Oh, that's right. Yeah, that's just program stuff. So on day one, we have site tours. Actually, if Zach's on, he's actually more facile in that. Can you say something about the tours, Zach?
Of course. So we're looking at holding 3 different tours.
On Monday, the 21st.
Yeah. And basically starting at 12 or 12:30. So a few things we're toying with. We know we won't be able to cover all of the sites that people want to show off. So we plan on having a list of kind of open to the public sites that, when you're in town, if you go to the Statue of Liberty, the concession stand on Liberty Island is heated and cooled by geothermal. So some places that people could check out independently. And we're toying with allowing members to offer their own site tour. We'll have an open house from 8 to 12, Monday the 21st. Stop by if you happen to find yourselves in the Bronx or, something like that. So that's kind of one facet of it. And then we're planning on having, my goal is 3 organized tours. One of them looks like it's going to be by subway. That would take us, to 2 Manhattan projects. One I think would take us to the outer boroughs of Brooklyn and Queens, and one would stay a little bit more central to where the conference was. I am working on identifying sites that we will have drilling in progress on during that point, so we can, try to add those. That would likely be a late addition, just because, with the exception of very large projects, we don't know exactly when they're going to be drilled. And then, we're thinking that it's going to be about $100 to sign up for one of the site tours. Each tour would be able to, accommodate 20 to 25 people. So we'll be able to have, 50, 60, 70, 80 people from, the conference be able to attend site tours the day before.
Thank you, Zach. Appreciate it. Well, we're at 4:01, folks. Time to
Hey,
start the
JR?
week. Oh, yeah, Bill.
Mind if I make a quick announcement if we're done with the conference discussion?
Sure.
Just want to let
board member privilege.
Just want to let folks know the Codes Council is supposed to be enacting the All Electric Buildings Act. And it's been a fairly tentative process they've been involved with so far. There is a Code Council meeting on June 28th, at which they are supposedly putting forward the plan for enacting the All Electric Building Act. There's going to be a prep meeting the night before at 6 o'clock. I put that in the chat. If anybody wants to be involved with making comments at the Codes Council meeting to make sure that they follow through, you'd be more than welcome to be part of that. There will be a conversation at 6 p.m. on Thursday, the 27th, and the URL is in the chat. Thanks.
Good way to wrap up, Bill. Appreciate it. Appreciate everybody participating, and we'll look forward to seeing you in 2 weeks. Have a great weekend, everybody.
Bye.
Thanks, everyone. Thanks, everybody.